Okay, so this is your EKS interface. So no, nothing big issue. So click on create cluster, and there is a quick configuration and a custom configuration. So let's go for quick configuration. So the cluster name is, by default they have given some name. So if you want, you can change the name to my EKS cluster. And the version, note down the version, it is 1.33, because the required packages, dependencies and all, we have to be using 1.33 version itself. The next, create role. So there are no roles for EKS. So let's create a recommended role. So you need not to worry. So AWS itself will create a role for it. You need to just select the service. Even nowadays service is also like auto selected. Just click on next, and create role. A role will be created. So EKS auto cluster role, and you can attach this role directly. So refresh, you will get the role, select the role and attach. And for node also you don't have any role, so we'll create a role for this as well. So create recommended role. So this time is for node service. Click on next, and create role. So that's it, role has been created. Click on refresh, update the role. So now we'll take default VPCs and default subnets. Click on create. So for creating this role, take some time, take some 2 to 3 minutes of time. So until this time, we'll try to download some minimum dependencies. For this purpose, let me go to EC2. So I don't require no roles and all, so I'll close this. Let's launch an instance. So EKS EC2. So the name of the instance is EKS EC2. Ubuntu version 22.04. T3.micro. Okay, this is in other region. Just a moment, in which region I have created the cluster? Okay, this is in Mumbai region. So your EC2 also should be in Mumbai only. EKS EC2 Ubuntu 22.04. Keypair, existing security group, default, and launch instance. So remember guys, we have to install two main packages here. One is AWS CLI and other is kubectli. So these two packages we need to install. So you know already how to install AWS CLI. So AWS CLI install. Go to the official website and we'll copy down these commands and install AWS CLI. So let's see if EC2 instance created. Okay, this is running. Connect to the server. So I'm installing unzip package. So there is a typo error. So meanwhile we'll copy these commands. And next AWS configure. So access key ID and secret access key ID. I think you guys know how to create it, right? So in IAM you will create. So I already have access keys. And secret access key. And region is AP-South-1. So no need of output format, just a blank enter. So let's verify whether my EC2 instance is able to communicate with AWS console. So as my buckets are reflecting, so that means my EC2 is communicating with AWS console. Now another package which I need to install is kubectl. kubectl install. So there will be an official website for this also from AWS. So go to this. So these are the installation steps. So I want this for Linux AMD. See, the version is 1.33, match with the version of your cluster. So let's see whether this is created. Okay, it's still creating. So leave it like that. And meanwhile, let's install our Kubernetes cluster. So kubectl, so copy this command, execute it here. And next, so proceed to second step. And the third step. And these are for Windows, so no need to do that. And check the version whether kubectl is installed. See, I can see kubectl is installed. Now we'll attach a EKS cluster to the EC2 instance. So we'll attach the Kubernetes cluster to our EC2 instance. So see guys, here we need to change some values. So region code is AP-South-1 and the name of the cluster. So what is the name of the cluster which I created? So this is the name of the cluster. So copy, paste and enter. So it will state, so cluster status is creating. So let's wait until the cluster is created. still creating. So for this EKS also you need ECR. So in our ECR, both in public and private, I have an image. So let's use that image for deploying it in EKS. Okay, so the cluster is active. So let's start adding this cluster. So the cluster is added. So use this command kubectl config current hyphen context. So if you use this command, it will show what are all the EC2 instances which are running. So I have a cluster which is running on my EKS cluster. So from here onwards, we have to create a manifest file. That means you have to push a Docker file from here to EKS. So after cluster is created, so guys, cluster alone cannot deploy a Docker image. So cluster alone cannot deploy a Docker image. So it needs some other resources called as agents or load servers to manage the workload. So for this, you can go to compute. For this, you can go to compute. So go to node groups, add node group. So node group name, my EKS node, and we have created a role in the beginning of the creation of EKS cluster. And scroll down. So we'll add some plugins here in the next page. So capacity on premises, so let it be T3.medium. So we don't require 2 nodes. As of now, we'll take only 1 node server. So let's enable auto repair. So these are the subnets in which I wanted my node servers to be alive. Click on create. So it will try to create some node servers. So meanwhile, so we need to add some plugins here. So go to add-ons. So you need some add-on which is CNI policy. So check for that. CSI driver, CSI. So we need core DNS. Yeah, so we need this CNI policy. Okay, that's it. We require only these two add-ons. Once these add-ons are done, click on next and click on next. If you want, you can create a node also. So let's give admin access for this. Click on create role. So role has been created. So attach the role. So this is custom JSON. So no need. So click on next and click on create. So even this node also will take some couple of minutes to perform. So let's wait until this node servers also gets created. So it is having some essential components like kubectl, control manager, scheduler, container runtime, and kubeproxy, etc. So I will tell you all the components and what is the function of each component in the theory section. Okay, so maybe tomorrow or fourth we'll have some theory discussion. So in that we'll detailedly understand why we can use, where we can use Docker, where we can use ECS, where we can use EKS. Okay, so you may have you already got a doubt like this. So you may have got a doubt. See, in even in ECS also we are deploying a container. Even in Docker EC2 also we are deploying a container, and even in EKS also we are deploying a container. Why can't we use any one? So I think in EC2 itself we can launch a image and run our application. But why can't we use only EC2 instance? You may have got the doubt. So we'll discuss why we are preferring EC2 instance over ECS and why we are using EKS over ECS. We'll discuss. So first let the core concepts get completed, then the understanding part and all we'll discuss. So as we are running out of time now, so I'm little rushing. It takes some time, so let's wait until the cluster and node group is created. So if you see here, by now one node has to be created. See, a node group has been created. if anyone is getting faster node creation, we'll make use of them. Maybe I expect my quota is over, so that's why it's taking too long. Someone try to create a cluster and node. Let's see for you it will happen quickly. But let's see, one node has been automatically created while creating a cluster. Hope this node group will not be supported, but anyways we'll try. So if you go to EC2 instances, so this is C6G large. So we have this C6 large. Let's try to deploy our application in this. So once after node servers are created, no? So let's see add-ons. Okay, add-ons are also active. So guys, once okay, so I'm getting this error. So the problem with this is, guys don't talk. So the problem with this is, your security group will not allow you to get the request, sir. So we'll go here. So this security groups belongs to EKS cluster. So in this security group, if you see here now, it is restricted. So we'll try to delete this add rule, and let's use all traffic as of now, and source anywhere IPv4, save rules, and let's try to get the node servers. See, one node is reflecting already, so we'll make use of this node server. So once even the node is ready, we have to create a file called deployment.yaml. So the syntax which you have to add in this EKS cluster is, search for deployment file for Kubernetes. So if you go to official website of Kubernetes, you will have a file called deployments. So click on this, you will be having a syntax. You will be having a syntax here. So this has to come up with a service as well. So copy this and execute it here. So this is just copy paste, but here you need to change some values. So what values you have to change here? So if you go to specifications, there is a container here. So in the place of container, so you don't have this image and you don't have this name. So for this purpose, what we'll do, we'll go to our ECR. So let's go to public repository. So copy your URI name and you have to execute it here. So change the name of the image and the name is, so let's use hello world as the name of the container. Now save and exit. So before exiting guys, if you observe in the specifications, there are 3 replica sets. So replica sets, why we need these replica sets in the sense? See, when there is a huge traffic, the normal EC2 instance where I install Docker will not support any auto scaling, first thing. Okay, so the normal EC2 instance where we configure Docker does not support any auto scaling and load balance. Next option where we have auto scaling and load balancer enabled is ECS. Right, in ECS we have option called load balancing and auto scaling. But what is the default of what is the demerit of using ECS? If you observe, did we enable any auto scaling in ECS? Did we enable any auto scaling in ECS? We have enabled only load balancing, but there is no auto scaling in ECS, right? So because of no auto scaling, what may happen? If there is no auto scaling, so actually, what is the purpose of auto scaling? What is the purpose of auto scaling? If there is heavy load, it will increase the resources depending on the traffic or network or requests. So if you have more traffic, what it will do? It will increase more EC2 instances, right? So in ECS, is that option enabled? We don't have that auto scaling option enabled. So in EKS, the benefit of using EKS is when any load has been increasing, the EKS cluster has a auto scaling policy. There are two auto scaling policies. One is HPA and VPA. If you want, you can note down. So Kubernetes has a auto scaling feature called HPA and VPA. It has an auto scaling policy called HPA and VPA. HPA stands for horizontal pod auto scaling. HPA stands for horizontal pod auto scaling. And VPA stands for vertical pod auto scaling. HPA stands for horizontal pod auto scaling. VPA stands for vertical pod auto scaling. So HPA, if we enable HPA, what happens? It will create multiple copies of pods. It will create multiple copies of pods, which you call it as a replica sets. The copy of pods is called replica sets. So as I mentioned here, as a 3 replica sets by default. So when there is a huge load, the HPA will automatically detect the changes and it will increase the replica sets by default. So you need not do anything. When there is a huge network flow, replica sets will be automatically increases. Whereas coming to VPA, capacity of the pod will be increased. Suppose if this is 20 GB, no, it becomes 25 GB. And if there is too much load, it will again increases to 30 GB, 32 GB, etc. So there will be only one node and one pod. But whereas coming to HPA, you will be having a single node but with multiple pods, multiple applications, multiple containers. So that's what I told the probability. Single host, single application, single container. You can use Docker. Single host, single container, multiple applications, ECS. Multiple containers, multiple applications, multiple deployments, you can use EKS, which is Kubernetes. So in this you have auto scaling option enabled by default. So when load increases, it will trigger the EKS node scaling policy and it will increase the node servers. So here by default I have given 3 replicas. So if you want, you can change it to 1 or 2. So no need of 2. So let's use only. So let's use some 2 replica sets. Save and exit. Once after deployment file is configured, so you call this deployment file as manifest. You call this file as a manifest file. So where you are telling the EKS to create a application, to go into ECR, select an image and do the deployment. So I am telling the EKS cluster to do the deployment. So to tell, I have to give a file. So that file is called as deployment file. So name of the file can be anything, but it should be in YAML syntax. So you don't write anything, you have already a file which is in the official website, you can just copy it and you can change the values. So I have done this. After deployment file is created, you can use this command kubectl apply -f and the name of the deployment file. So guys, after you do this now, you have to again run a service. So instead of running a service and creating a deployment file, so we'll directly have a deployment file along with the service. So we'll see where the service is located. Actually, this should have a service file as well. Yeah, so we'll use this. So we'll use this here, and let's copy this. And instead of using this deployment.yml, so let's change the deployment file. So guys, if you observe here, so the first is service and next I have deployment. So the service type will make use of we'll take load balancer, or else first we'll set this to node port. First we'll set this to node port, so later we'll change this to load balancer. And the name of the image is your ECR image. So the type is node port. Next you have in the place of image you have to write the image which you have in the ECR. Put it here. So name, let it be like this, no problem with the name. Save and exit. So after you configuring the deployment file or manifest, this is the command kubectl apply -f and name of the deployment file. So this will create a service as well as a deployment. So to see the deployment, kubectl get pods. See, I have 3 pods running. So by default this will be in pending state. So let's wait for the pods to change to running state. So it's creating containers. Okay, now the status of pods is ready. So the status of pods is ready. Now we need a service for this. To expose the service, kubectl get svc. So if you use this, see, this is the node port. So what do you understand by this? So this is the container port number and this is the host port number. This is the container port number, this is the host port number. So now we have to make the application alive by using this port number. So this process is called as ingress. This process is called as ingress. INGRESS. Note down what is ingress. So in interviews they will ask you what is ingress. Ingress means exposing the application publicly with the help of a port number created by Kubernetes. Exposing the application publicly with the help of port number or host port number, which is created by Kubernetes. This is called as ingress. So now let's access the application. For this I need my EC2 instance. So this is the EC2 instance, which is c6.log. So see guys, it started creating another EC2 instance because it has detected some load in it. So let's copy this. So before copying it, go to security and check the inbound numbers, inbound port rules. Okay, so this is set to all traffic only, so no problem. So let's check the other security group also. So even this also have all traffic enabled. So now copy the public IP address and you have to expose the application with the help of 32579. 32579 colons. Okay. See, you can see application has been deployed. So we know we should not expose the public IP address, right? So in order to do that, we can change the node port to load balancer. So how to do that? In the console, kubectl edit svc and the name of the service. kubectl edit svc and the name of the service. So here if you can see, type is node port. So if you don't want to expose your public IP address, you can change this to load balancer. So you can change this to load balancer, save and exit, and rerun the changes. And now check kubectl get svc. So you will have a load balancer which is created here. So we already have a EC2. If you go to load balancer, Even here also change it to load balancer and kubectl apply -f deployments get pods. So pods are running. kubectl get svc. See, instead of node boot you have a load balancer here. So this will be in a pending state. So if you wait for some time, an external IP will be created and this will trigger a load balancer, and if you ping the load balancer DNS, your application will be deployed. So it's already deployed, it will be accessible. So meanwhile, if you wanted to edit the svc, no, so this is the command. So kubectl edit svc and provide the service name. So here it is load balancer only. So it takes some time for the load balancer to create. So once the load balancer is created, you can open the load balancer and ping your DNS. That I think you can do. Okay, so I'll stop the recording.